just to kind of re-summarize what it is that we've been doing, okay? Does that sound all right? Good. So, to review here, the first thing we do is we're going to use the fundamental theorem of algebra to determine the total number of solutions. How do I do that? Good. The biggest exponent or highest degree is the number of solutions that we're looking for, right? Then we use the rational roots theorem to come up with the possible rational solutions. How do I do that? Okay, so factors of, I'm going to say constant term there instead of last, but okay. What else? There's some other parts missing. Okay, good. Factors of, and I'm just going to write LC instead of leading coefficient. And you guys are all forgetting one other thing. Plus or minus. There you go. Okay. So don't forget about these. Oftentimes leading coefficient is 1 and we don't have to worry about it. But if that leading coefficient isn't 1, that makes a big difference to our list, right? Okay. Okay, after this we're going to graph. From the graph we're going to get the real solutions. When I say real, that means rational and irrational, right? Everything other than the imaginary pieces. How can I tell the difference between rational versus irrational? Excellent. Okay, so the rational solution should be the ones that you find in that list. If it's not on that list, then it's irrational. If I think that solution is on the list, though, does that guarantee it to be rational? Not necessarily. It could be something that just is like hard to tell the difference, right? Like the square root of 2 and 1.5 are so close that it would be tough to tell the difference until you went and tried to do the synthetic division with it. Okay, so that's one thing we can get from the list, or from the graph. We get these real solutions, so we can tell the difference between the rational and irrational ones. What else can we tell from the graph? Great. We can use the bend, bounce, straight. And that gives us the, I'll say number of repeats. How about that? Is everybody good with what I mean there? Okay. So from the straight, how many times is that going to get used? Once. Okay. The bounce. Yeah, even, so like 2, 4, 6, etc. Bends. Odds starting at 3, so 3, 5, 7, etc. Everybody's okay there? Okay. So those are three really important things we get from the graph, right? We get the real solutions. We can tell the difference between the rational and irrational now. And I should be able to tell which ones repeat and to some extent how many times they may repeat, right? Okay. So the next thing I'm going to do is build a table of possible solution sets. And what that table is going to allow me to do is it allows me to check for the possibility of having imaginary solutions. Everybody okay with that idea? Let's do a quick example of this because this feels like a place that most of us don't feel great about. Okay? So I'm just going to make up some stuff and we're going to build out a table from this. So let's say this is the information that we have. We have 10 total solutions. We're able to tell that we have a bounce at x equals 1, a bend at x equals 3, and we have irrational solutions at negative 1.5 and positive 1.5 that are straights. So the way I'm going to build my table is I'm going to put a spot for each of my rational solutions. And then I'm going to just make a spot for the irrationals, a spot for imaginaries, and then a total. So the total is always going to be 10, right? The irrationals in this case is always going to be 2. So the bounces, what's the least number of times that 1 or x equals 1 could be used? 2 times. What's the least amount of times x equals 3 could be used? 3. Okay? For the irrational parts, because I have 1 of them, 2 of them, because they're going straights. Right? So they're used 1 time each. Is that okay? Did I make up something that can't happen? I think I did. That needs to be a 9. My apologies. I'll just do that. Okay. So now, 2 plus 3 plus 2 gives me 7. I need to get at 9 total. Where are the other 2 solutions going to come from? Imaginary. Okay. Is this the only situation that could happen? No. What else could happen? So what if x equals 1 is used 4 times? This could still be used 3 times, still have 2 irrationals, and still have to have a total of 9. What does that tell me? No imaginaries. But that's not the, could there be something else? What else could happen? What if this was used 2 times, this used 5 times, got to be used twice, got to have a total of 9. What does that tell me? 0. Could those be used 4 and 5 times at the same time? Right? Because that's now too many. Can't happen. Is everybody okay on how I built this table? So those are the those are the 3 possibilities. Until we start the synthetic division, we don't know which one of these 3 possibilities there are. What it tells me is there's absolutely a possibility of getting imaginary solutions in here. I don't know that I will after I build my table, and you won't ever know for sure just by looking at the table. You'll know if it's impossible to get imaginary solutions, but the best we can do is detect whether it's possible or not. You can get impossible or possible, but you can't get for sure from the table. Is everybody okay with that? Madison. Because now we're going to be... Right, so if I went higher and this was like 6, the least that can be is 3. That has to be 2, and that gives me 11, which is too many than we have. Correct. So you can't go past the total, right? So you can just kind of play with the combinations there until you get to the total. Once you go past the total, can't use that one. Does that feel okay? Olivia.
So we have no irrational numbers, like 0.
Correct. And the irrational part really usually never changes. Also a helpful hint, these 2 columns are always even. So those always have even numbers in them. The reason is because of the irrational conjugates theorem and the complex conjugates theorem, guarantees that if I have one irrational solution, I also have to get its conjugate, which is another irrational solution. Or if I get one imaginary solution, I'm always going to get its conjugate. Those imaginary solutions and irrational solutions always come in pairs. Okay? Katie. Sure. Okay. So the next step, we've built our table. So the next thing we're going to do is use our synthetic division to factor. So based on what we know to this point, we know which of the numbers to use to do the synthetic division, right? We've identified the rational ones. We know how many times we can do the synthetic division with those at the minimum, because we've identified the bend, bounces, and straights, right? So usually at that point, the factoring becomes pretty easy. It's just a matter of kind of confirming things at the end, right? Okay. And then our last step is to set these factors equal to 0 and so on. So what is going to be an extremely limiting factor if you're unable to do this? If you can't get your calculator to output a decent picture, it makes the rest of this process really a lot more difficult, right? Okay, how many of us are still having trouble getting our calculator to output a decent picture? It's okay. So there's still several of us that are having trouble with this, and probably several more that are just too shy to raise their hands or too disinterested to raise their hands. This is a skill you need to develop if you're not already able to do this. Let's run through how we can do this one more time, okay? So let's look at an example, and the example I'm going to pick right now is quite a complicated one, so that like all the little weird things that can happen, we can talk about during the course of a problem like this. Now, I think this problem is probably something that's too lengthy for me to ask for you to do on a test, because realistically, I probably couldn't ask you to do much more than just this one single problem. At least without guidance, but not unreasonable to use as an example problem for us to kind of work through together. So it gives us a lot of things to talk about. Well, it's got 11 terms because it's a degree 10. So you don't have to get all fussy about it. All right. So before we do anything else, what two things should we list here? So we have 10 solutions, right? Everybody agree with that? Okay. And then we can list our possible rational solutions. What are those going to be? Not 3. You can tell if something's divisible by 3 if you add the digits. That number, if that number is divisible by 3, then it's also divisible by 3. But 5 plus 11 is, or 5 plus 6 is 11. That's not divisible by 3. That's a nice little check. So that one doesn't work. 4 is though. 7, 8. What else do we got? 14, I think. 16, nope, not 16. 28, I think is the next one. And then 56 is the last one, I think, right? That one, that one, that one. Yeah, that's it. Okay. Now we're going to look at the graph. So fire up our calculator. Where do I go to type this in at? Y equals. So I'm just going to type this in exactly as it looks on my sheet of paper. It's going to take like a half an hour to type it in because it's a million things long. Start typing it in, especially if you are one of those people that has had trouble getting the graphs to output. So you got to be careful when you're typing this in. If you don't type it in correctly, that's going to give us problems. So go slow. Make sure that you don't forget something. Oops. Or type in something wrong like I just did there. Okay, you guys got them in? Anybody still typing? Leslie, you good? Okay, I'm just asking as I saw you pressing buttons. Next thing, what do we do then? We're going to go to our window, and we're going to pick a max and a minimum for the x's. How do I pick the maximum minimum for our x's? Yeah, pick the biggest and smallest number off of our list. So that's negative 56 is the smallest, and positive 56 is the biggest. The x min gets the small number, x max gets the big number. The y mins and y maxes I usually just leave at negative 10 and positive 10. It'd be a rare exception to where I would need to change those. Almost always will they be fine. Now let's hit graph. Well, that picture sucks, right? Did I do something wrong? No, just all the spots that I'm interested in are really tight up against the y-axis. So I just need to change my window a little bit. So out here we're at like negative 50. If I cut that in half, we're at negative 25. That's still too much empty stuff, right? If I cut it again, we're at like negative 12. Still a lot of empty. Cut it again, we're at like negative 6. That's probably good enough. So let's change it from negative 6 to positive 6 and see if that gives us a good enough picture. So all I'm doing is just trying to estimate in my head how much of that can I chop off and still have the parts that I'm looking for. So I change that to negative 6 and positive 6 and hit graph again. Okay, that's good. So, look at the picture. What are the x-intercepts that you see? So you said what? 2.7. I think probably negative 2 points. Oh, there's positive 1 also, I guess. So we can say negative and positive 2.7, sure. Everybody good with that? Okay, what else do you see? Negative 1. That's that one right there. Okay, what else do you see? What's this one? Positive 1, I think so too. And then what's this one here? Positive 2, I think so also. Okay. From these, which ones are irrational? Yeah, the ones that are decimals, right? How do I know they're decimal? How do I know the decimals are going to be irrational? Yeah, my list is all integer values, so. And if you check, it's easy to see that all negative 1, positive 1, and positive 2 are all on the list, right? So those are rationals. Okay? Also, we should look for whether they are bend, bounces, or straight. So negative 2.7, is that a bend, bounce, or straight? That's a straight. How about positive 2.7? Also a straight. Okay. Negative 1. I agree, bounce. Okay. Positive 1. I think that's a straight. If you look just right here, that looks straight to me, right? You were just looking one to the right? Yeah. Yeah, this one is a bend. I agree on that. Everybody's okay there? Okay. So let's build out our possibilities. So let's make our table then. So the rational ones go in my table. The irrational ones we're just going to put under a blanket column called irrational. And then I have my total over here. So that much I can say right off the bat, right? Total of 10. X equals 1 is a straight, so that's used one time. Each of my irrationals are straight. Those are each used one time, so that's total of 2. 1 for each of them. What's the minimum number of times a bounce can be used? What's the minimum number of times a bend can be used? So 2 plus 1 plus 3 plus 2 is 8. So I'm short 2 of them. They have to be imaginary. Okay, what's the next other? So bounce could be used also 4 times. So I'm going to keep everything else the same. So 4 plus 1 plus 3 plus 2 is 10. So I can't have any imaginaries. But a bend could also be 5 times instead of 3 times. So what if I had 2, 1, 5, 2? That gives me 10. But if I increased both the bounce and the bend to 4 and 5, that would be too many, right? Then I would end up with 12, and that's too many. Everybody's good? Okay. So can I have imaginary solutions here? Yes, I could. Okay. So let's start our synthetic division. What number do you want to use the synthetic division, or what do you want to start with? 1? 1 is fine. 2 would be fine. What's a number that's not fine? Yeah, the 2.7 and negative 2.7. You do not and cannot use the irrational ones. Those are bad news. Now, somebody asked me earlier today, does it matter the order in which I pick my numbers to do the synthetic division? What do you guys think the answer is? Sometimes. Now, we haven't yet run into a situation in which it did matter. Right? After all the problems that we've done, it wouldn't have mattered. There is a case where you could, we'll talk about what that case would look like here later. To avoid that, my suggestion to you guys is to always do the straights first. So the ones that are rational and straight. If you do those first, I think everything works out. Even in that weird situation where maybe the order mattered. If you do that order, you'll catch it every single time. Now, that's not something I would give to you on a test. In a course like this, that's way beyond the scope of what I'd expect you guys to be able to do in a test setting. But just to let you know, some people had asked about that. And it's a reasonable question, right? That's an important question. Does the order I do this matter? Almost always the answer is no. But to make it always like this is going to work out nicely for me, if you do the straights first, then things usually work. I think it's impossible to come up with a situation where that would go poorly for you. I'd have to really sit down and think about that, but I think that will work every single time. Certainly avoids the situation that I can think of right off the bat where the order would matter. Okay. Of course. 28. Oops. If anybody sees any arithmetic mistakes, please stop me beforehand before they get too far. I don't want this to turn into a big mess. Oh, good. That did work. You know, you always assume you can do arithmetic, but after 4 classes and not enough sleep, you never know, right? All right. What do you want to do now? Can I use 1 again?
No.
No, why not? Very good. It's a straight. Can only be used once. What do you want to use next? -1. Great. That sounds good. Oh, I would definitely wouldn't give you something this big. Would not. No. This is, you would not have time to do this. I mean, to do anything else. We'll talk a little bit more about what the test format would look like, but you're not going to have to solve a lot of these things. I would probably only ask you to do like 1 all the way through. And then we'll talk about what the other problems might look like. Okay, so that worked. What do you want to do next? Let's do -1 again, right? How many times could I use that? At least twice, right? Because it's a bounce. So I'm going to use it the 2 times. After that, though, I might change and try something different. Oops. Not 46, 45. Okay. What do you want to do now? At this point, I would change to +2. Now, it's possible that -1 would work again, but you don't know. And rather than wasting your time, I would change to +2 that we know is going to work 3 more times. Right? Is everybody okay with that? The reasoning there? So that's 1 time. That's a 2nd time. That's a third time. Uh-oh. Everybody's good? So far, so good? Wait a minute. Anyways. Okay. Now what do you want to do? I heard some mumbling, but I didn't catch it. Sure. That's not an unreasonable thing to try. What do you want to do first? 2 or -1? Okay. That didn't work. Let me erase. Let's try 2 then, right? Didn't work either. Uh-oh. So what happened here? Because I want to show you like worst case scenario kind of thing.
This is the darkest time.
That's worse than
This
This
is
is
dark.
the darkest day.
Okay. So a moment ago when I talked about order mattering, I misspoke about one thing, okay? So I want to go back and retract on this. So I said to do the straights first. I meant last. And that's a big difference. Let me explain why we want to do that. Okay? So what's going on here, this is a 4-term polynomial, right? This is like x to the 4th plus x cubed minus 6x squared minus 7x minus 7. What's likely going on here is I have like a 3-term polynomial, 3-term with degree 2, times either another 3-term or a 2-term, I'm not sure, that's also degree 2. Yes, of course. So this situation where I have, what I'm hoping for is a 2-term degree 2. Something that's like a difference of 2 squares or possibly a sum or difference of 2 cubes to find along the way. If I can find a situation like that, that's what I'm hoping for, because that'll allow me to factor this with my factoring tree, because I'm not going to be able to finish it by grouping or by synthetic division. So I'm just going to start back over, and I'm going to try saving that degree 1 term for later. I know, guys, just relax. It'll be okay. It really will. I know you're angry. It's okay. Yeah, of course they wrote it all out. It doesn't matter, guys. It's just paper. And, well, did you not learn anything?
Limited amount of paper.
You guys learn stuff. It's fine. So I'm going to start, instead with 1, I'm going to start with -1. Or wait a minute, let me think. I'm going to start with 2. That guy. And I want to tell you right now, would I reasonably put something that the order mattered on a test? For you guys, heck no. What happened here? What did I goof on? All right, whatever. I don't care about this anymore. You guys, you know what? Here's the thing, guys. You got out of this what I wanted you to, was to see that sometimes order matters, right? We picked something willy-nilly, and it didn't work out. Let's just stop. Because you guys are frustrated. That's fine. That's what I wanted to have happen. Let's just stop. Okay? And I'm